All right, so today we're going to look at acids and bases and the pH scale and the characteristics of each of these and what is an acid and what is a base. And then on tomorrow we're going to discuss neutralization reactions. So today we're looking at these acids and bases and pH scale. So the characteristics of acids, and you've probably heard of acids, in your household materials. But acids, they usually have a sour taste. So if you've ever tasted like a lemon or vinegar, white vinegar especially. They're very sour. They react really well with metals. And some examples in your house of acids are lemons, vinegar, some pop would be also an acidic. Eats away the enamel, okay, of your teeth. An acid is a compound that is dissolves in water, and usually, for the most part, we carry acids in dissolved in water. Okay, so usually they're aqueous solution. So an acid is a compound that dissolves in water to release hydrogen ions in the solution. Okay, so a hydrochloric acid is HCl. Okay, and there's lots of hydrogen ions that dissociate from the chlorine ions. You remember how when we put salt in the water, it disassociates into sodium and chloride. Well, this is what acid does in water. When it's aqueous, it dissolves into hydrogen and chlorine ions. Okay, and these hydrogen ions and chlorine ions get separated by the water molecules. So the characteristics of bases. Bases are the opposite of what's it called? Of acids. Okay. Characteristics of bases. Chemical opposites of acids. The adjective alkaline is sometimes exchanged for basic, and it's not like basic where you're going to get pumpkin spice lattes. Basic means alkaline, so it's the opposite of acids. Some basic stuff in your house, or alkalinic stuff in your house, or whatever you want to say. Basic, not you know uh, pumpkin spice lattes, but some other basic things in your house would not your sister or whoever else drinks those things, but baking soda would be basic. Your Windex Drano would be basic. Okay, and they often feel slippery and have a bitter taste. Um, so you're going to see basic solutions, something slippery. One example would be, say, soap. Soap is very basic. Is basic. Okay, and it will not react with metals. Okay, example of bases again: baking soda, Windex, Drano. Um, and soaps in your house. So a base dissolves in water to produce something called hydroxide ions, and we learned about hydroxide ions in polyatomic ions, and this is the hydroxide ion. It's an oxygen and a hydrogen with a negative charge in the solution. Okay, so remember again, polyatomic ions are considered one atom. And so when you dissolve sodium hydroxide in water, and sodium hydroxide is Drano, it's very, very poisonous. Okay, so Drano, when you dissolve Drano in water, what happens is sodium ions dissociate from the hydroxide ions, get surrounded by the water, and the hydroxide ions produce the base. Where if you looked at the acid, it was the hydrogen ions. It's different, right? One is hydrogen, the other one is hydroxide. Okay, we have these things called acid-base indicators, such as litmus paper. Okay, and these acid-base indicator is a chemical that changes color based on the concentration of hydrogen ions or hydroxide ions. Okay, so you can do that with hydroxide ions or hydrogen ions. Okay, and it changes the colors either red with acid, so lots of hydrogen changes it red, or lots of hydroxide changes it blue. Okay, the main use of the test is whether the solution is acidic or alkaline. Okay, so yeah, that's basically what that litmus paper is for. Okay, we also have phenolphthalein. Phenolphthalein is a colorless for acid and pink for base. So when you put base in it, something basic or alkaline in it, it's going to turn it pink or purple. And then for if you pour like hydrochloric acid, the high ions dissociate and you just get a clear solution. We have this thing called the pH scale. And I'm sure some of you have heard of the pH scale. And the pH scale compares the strength of acids and bases. Okay, neutral is 7. So the lower you are on the pH scale, the more acidic you are. The higher you are on the base scale, on the pH scale, like 14, you're basic or alkaline. The water that we drink is usually 7, is right at pretty much right at 7, might be 7.2, 7.5. okay, 6.9, 6.8. But again, the pH scale, the neutral is at 7. So if I say I have an acidity of 2, you can assume that that is extremely acidic. It's not more neutral, it's extremely acidic. If I say I have a pH of 13, you can expect that to be very alkaline. Okay, so 0, very strong acid, lots of hydrogen ions. 14, very strong base, lots of hydroxide ions. Okay, 7 where hydroxide and hydrogen ions equal, they're equal in number. Okay, so they kind of cancel each other out, right? Because we see that a hydrogen ion is positively charged and a hydroxide ion is negatively charged. So what happens is they bind together and they're attracted to each other and they form just neutral, pretty much just neutral water, right? You look at this, right? You got H plus an OH negative, and two H's plus an O is a water molecule. Okay, so they cancel each other out because this is a positive, this is a negative, and this is a positive, and you have drinkable water. Okay, to determine the pH of a solution, universal indicator pH paper or a pH meter can be used. You can see here this is very acidic, and as you move more to the purple range area, you're getting more basic. This is what a pH meter would look like. If we were in class, we'd be doing a few what's it called? A few experiments with this, but this is basically what it looks like. Basically, this is get it because it's basic. This is what the meter would look like, and again, if we were in class, we'd be using it quite a bit. And that's about it, all you need to know for acids and bases. We will talk about neutralization reactions in the next lessons. Take care, guys.